Hello, welcome to Visionaryx, our podcast where you can have real and simple conversations with us about various tools and technologies. I'm AWS and
I'm Azure. In this podcast, we dive into exciting discussions about simple and deep technical topics in the world of DevOps and cloud.
I'm Google Cloud. You can find the full transcript of this episode on our website visionaryx.tech to follow along with us. Stay tuned and enjoy the adventures in the world of technology.
Hello friends. Today we talk about making a new cloud. Let's start with what cloud computing is. Azure, can you tell us what cloud computing means?
Of course, the standard definition is cloud computing is a paradigm for enabling network access to a scalable and elastic pool of shareable physical or virtual resources with self-service provisioning and administration on demand. This definition has key ideas like scalability, flexibility, and resource sharing. Google Cloud. Which part do you think is most important?
I think the self-service provisioning and administration on demand part is really important. This lets users get resources fast without the provider's help. AWS, how do you make this work in your system?
We make this possible through our management console and automated APIs. But let's look at the concepts more deeply. One of the key features of cloud computing is measured service. Azure, can you give us the exact definition of this concept?
Yes, the definition is measured service is a characteristic in which the metered delivery of cloud services is such that usage can be monitored, controlled, reported, and billed. This lets us measure and manage how we use things very well. Google Cloud. How do you do this in your platform?
We use good systems to watch and report how we use things. This helps us make bills and use things better. But let's talk about another big idea, multi-tenancy. AWS, can you tell us what this means? This lets us see how we use things very well. We use cloud service-derived data. It means cloud service-derived data is a class of data objects under cloud service provider control that are derived as a result of interaction with the cloud service by the cloud service customer.
Of course, the definition says multi-tenancy is a characteristic in which physical or virtual resources are allocated in such a way that multiple tenants and their computations and data are isolated from and inaccessible to one another. This is really important to keep people's things safe and separate. Azure, how do you make multi-tenancy work in your system?
We use good ways to keep everyone's work and data apart. But let's talk about another big thing, cloud service categories. Google Cloud. Can you tell us the main types of cloud service categories? To make things even safer, we also use secure multi-tenancy. It means secure multi-tenancy is a type of multi-tenancy that employs security controls to explicitly guard against data breaches and provides validation of these controls for proper governance. These ways help us keep everyone's work and data safe and apart from others. It's really good.
Yes. The main types of cloud services are software as a service, SaaS, platform as a service, PaaS, infrastructure as a service, IaaS. There are other types too, like network as a service, NAS, and communications as a service, CaaS. AWS, can you tell us what IaaS means?
Of course. The definition says infrastructure as a service, IaaS, is a cloud service category in which the cloud capabilities type provided to the cloud service customer is an infrastructure capabilities type. Here, users can control the system, storage, and apps, but not the big parts. Azure, what are the good things about IaaS?
IaaS is really good. It's easy to change, gives more control, and can grow fast. People can get just what they need and save money. But let's talk about another big thing, cloud deployment models. Google Cloud. Can you tell us the main types of cloud deployment models?
Yes. There are 4 main types of cloud models: public cloud, private cloud, community cloud, hybrid cloud. Each of these is different. AWS, can you tell us what hybrid cloud means?
Of course, the new definition says Hybrid cloud is a cloud deployment model that uses a private cloud and a public cloud. This lets people use good things from both public and private clouds. Azure, what do you think are the hard parts of making a hybrid cloud?
The big problems are managing things together, keeping data safe when it moves, and making sure apps work in both places. But let's talk about another important part of cloud computing, cross-cutting aspects. Google Cloud, can you tell us some of the most important cross-cutting aspects?
Yes. Some of the most important cross-cutting aspects are security, privacy, interoperability, portability, reversibility, performance, governance. All of these are really important when making a cloud system. AWS, can you tell us why interoperability is important in cloud computing?
Of course, interoperability, which means systems working together, is really important in cloud computing. The definition says, cloud interoperability is the ability of a cloud service customer's system to interact with a cloud service, or the ability for one cloud service to interact with other cloud services by exchanging information according to a prescribed method to obtain predictable results. This lets people use many cloud services and move their data and apps between different systems. Azure, how do you make interoperability work in your platform?
We use open standards and public APIs to make sure our services can talk to other systems. We also have tools to move data and apps between different platforms. But let's talk about another big idea, cloud data. Google Cloud, can you tell us the main types of data in the cloud?
Yes. The main types of data in the cloud are cloud service customer data, cloud service provider data, cloud service derived data, account data. Each of these types of data needs special care. AWS, can you tell us what cloud service customer data means?
Of course. The definition says, cloud service customer data is a class of data objects under the control, by legal or other reasons, of the cloud service customer that were input to the cloud service or resulted from exercising the capabilities of the cloud service by or on behalf of the cloud service customer via the published interface of the cloud service. This is the data that people put in the cloud or get from using cloud services. Azure, what do you think are the big problems in keeping cloud service customer data safe?
The big problems are keeping data safe and private, following data rules in different places, and giving people tools to control their data. Also, making sure data can move between services and be got back if needed. But let's talk about another big thing, virtualization. Google Cloud, can you tell us what virtualization is and why it's important in cloud computing?
Of course. Virtualization is a really important thing in cloud computing. The definition says, virtual is not physically existing as such, but made by software to appear to do so. In the cloud, we use virtualization to make fake versions of real things like servers, storage, and networks. This helps us use things better and do cool stuff like multi-tenancy and quick changes. AWS, what virtualization tricks do you use in your system?
We use many virtualization methods like 1. Virtual machines, VMs. The definition says, virtual machine, VM, is an isolated execution environment for running software that uses virtualized physical resources. 2. Containers. The definition says, container is an isolated execution environment for running software that uses a virtualized operating system kernel. 3. Hypervisors. The definition says, hypervisor is software that virtualizes physical resources and allows for running virtual machines. Each of these ways has good things about it. Azure, what do you think are the good things about using containers instead of old VMs?
Containers are really better than old VMs. They have good things like 1. Less overhead. Containers use the host system's kernel. They don't need a separate operating system, so they use fewer resources. 2. Easy to move. We can move containers easily between different systems. 3. Start faster. Containers can start in seconds. VMs can take minutes to start. 4. More dense. We can run more containers on one real server. But let's talk about another big thing, cloud service agreement. Google Cloud, Can you tell us the main parts of a cloud service agreement?
Yes. A cloud service agreement, CSA, usually has these main parts. 1. Cloud Service Level Agreement, Cloud SLA. The definition says, Cloud Service Level Agreement, Cloud SLA, is part of the cloud service agreement that includes cloud service level objectives and cloud service qualitative objectives for the covered cloud services. 2. Cloud Service Level Objectives, Cloud SLOs. The definition says, Cloud Service Level Objective, Cloud SLO, is commitment a cloud service provider makes for a specific, quantitative characteristic of a cloud service, where the value follows the interval scale or ratio scale. 3. Cloud Service Qualitative Objectives, Cloud SQOs. According to the definition, Cloud Service Qualitative Objective, Cloud SQO, is commitment a cloud service provider makes for a specific, qualitative characteristic of a cloud service, where the value follows the nominal scale or ordinal scale. These parts help say what the cloud provider must do and what the customer can expect. AWS. Why do you think having a good cloud SLA is important?
A good and full cloud SLA is important for some reasons. 1. Clear rules. It lets customers know what kind of service they can get. 2. Trust. It shows the provider will give good service. 3. Managing expectations. It helps prevent misunderstandings and possible disagreements. 4. Being responsible. It gives a way to check how well the provider is doing. 5. Making things right. It usually has rules for paying back if the SLA is not met.
How do you make sure you follow your SLAs? We use many ways to make sure we follow our SLAs. 1. Continuous monitoring. We have advanced systems that constantly watch our services' performance. 2. Automation. We use automatic systems to find and fix problems before they affect the SLA. 3. Redundancy. We use very reliable and spread out systems so if one part has a problem, the service still works. 4. Continuous improvement. We always work to make our processes and infrastructure better, to increase performance and reliability. 5. Team training. Our technical teams learn all the time to fix problems quickly. Let's talk about another important thing, cloud computing roles. Can you tell us the main roles in cloud computing?
Yes, the main roles in cloud computing are 1. Cloud Service Customer, CSC. The definition is, Cloud Service Customer, CSC, is a party that is acting in a cloud service customer role. 2. Cloud Service Provider, CSP. The definition is, Cloud Service Provider, CSP, is a party that is acting in a cloud service provider role. 3. Cloud Service Partner, CSN. The definition is, Cloud Service Partner, CSN, is a party that is acting in a cloud service partner role. AWS. Can you tell us more about the Cloud Service Customer role?
Of course, the Cloud Service Customer, or CSC role, is very important. The definition is, Cloud Service Customer role, CSC role, is a set of activities for the purpose of using cloud services. This role includes activities like selecting and purchasing cloud services, using services, managing and monitoring service usage, and integrating cloud services with existing systems. Azure, what do you think are the main challenges CSCs face?
CSCs have many challenges. These include managing costs, making sure things are safe and follow rules, and dealing with the complex issues of using many cloud providers multi-cloud. But let's talk about another important idea, cloud application portability. Google Cloud, can you explain this?
Yes, the definition is, Cloud application portability is the ability to migrate an application from one cloud service to another cloud service. This lets customers move their programs between different cloud systems. AWS, how do you support cloud application portability?
We use open standards and things like containers to help with portability. We also give tools to move programs. But let's talk about another important thing, availability. Azure, can you tell us what availability means?
Yes, the definition is, availability is the ability to be in a state to perform as required. This is a very important idea in cloud computing. It's usually in SLAs. Google Cloud. How do you make sure your services have high availability?
We use techniques like geographical distribution, redundancy, and load balancing. We also use the concept of availability zones. AWS, can you explain the concept of an availability zone?
Yes, the definition is: availability domain or zone is a logically and physically isolated location within a cloud region. This idea helps us give very reliable services. Azure, what other important ideas are there about how cloud computing is set up physically?
Ideas like cloud region and geodispersion are very important. The definition is: cloud region is a geographical area containing a set of physical resources used by cloud services that are independent and isolated from the physical resources contained in other geographical areas. And geodispersion is placement of two or more resources so that they are geographically separated from each other. These ideas help us give services with low delay and high reliability. Google Cloud, can you talk about why interoperability is important here?
Of course, interoperability, or the ability of systems to work together, is very important. We have different types of interoperability, like syntactic interoperability and semantic data interoperability. The definition is: semantic data interoperability is interoperability so that the meaning of the data model within the context of a subject area is understood by the participating systems. And syntactic interoperability is interoperability such that the formats of the exchanged information can be understood by the participating systems. AWS, how do you support these types of interoperability?
Okay, let's pause our discussion here. We've covered a lot, but there's still so much I wanted to talk about. For example, I wanted to discuss reversibility, public domain data, personally identifiable information, mixed datasets, failure notification policy, and many other topics. We'll save these for our next episode, which will be the second of infinitely many sessions we plan to have with the three of us, and possibly even more of our friends.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website visionaryx.tech.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website visionaryx.tech.
Next time, we'll be talking about gRPC and Apache Cassandra. Goodbye for now.
Goodbye.
Goodbye.